Hi everyone, my name is Mats Kwamon and I'm going to present you a project about AI-powered waste sorting system. I think let's get started. Let me share the screen so that you can be able to see. We are going to use AI with machine learning as a subset to perform this project. And basically the problem we're looking at is waste. As we all know that the world and mostly developing cities are grappling with the problem of waste management. And this has led to stinky smelling instances in cities whereby due to poor waste management, and this has led to infections and diseases to the people that are living in these cities due to poor waste management. And what does this bring? What does this purpose of ours bring to solving this problem? Basically, here we're going to use machine learning, and in this, we are going to train algorithms that will be able to sort the waste effectively in the least time possible at the least cost. Let's dive into it right now. So basically here we're going to first look at the three methods that we shall use to train our algorithms. And basically this ones include the supervised, unsupervised, and reinforcement learning. What are these ones? Supervised learning, basically this refers to the training of a data set using models to yield a desired output. Basically here we train the models using using known inputs and correct outputs, in which we'll allow the model to learn over time, and here we use the labeled data. So unsupervised learning, here basically we use unlabeled data, which is not the case with supervised learning, and this happens in a way that the algorithm will learn by clustering data depending on its similarities and patterns. So this will particularly be useful when the subject matter experts are unsure of the properties within the data set. And reinforcement, basically this one is where the AI model tries to take the best possible action in a given situation to maximize the total profit. The model learns by getting the feedback from the past outcomes. So basically that's a recap of the three. So in context of labeled data, we are talking labeled data in supervised learning. Basically labeled data will mean input data point in relation to a project that will be image of the waste is paired with the corresponding output label. Basically, we shall say, let's say in this we mean like the type of waste, e.g. plastic, metal, or hazardous or non-hazardous. The algorithm will learn to make predictions and classification by generalizing the patterns from the labeled data. Here, supervised learning will be highly applicable in identifying the categories and the different types of waste. And the goal here basically is to teach the algorithm to recognize the specific patterns and features in the waste images that will be provided to it. If we are to understand the applicability in waste sorting of, here I mean supervised learning, its applicability in our project of waste sorting, we shall use algorithms such as the conventional neural networks, the CNNs. And this one is particularly effective in image classification, as you all know that, as I've told you, we shall basically be dealing with images, because these images, we shall be using them to classify, we shall be using them to classify whether hazardous, non-hazardous plastic, or So basically this one is very effective in image classification, and that's why we are using it, because it uses hierarchical representation of features of images. So basically this one will help us in solving classification problems in waste sorting, which will involve assigning images to a certain category or class, and the algorithm will learn to make predictions based on the visual features extracted from the labeled images. We can also look at, we shall look at labeled data, and this labeled data, the role of labeled data. These labeled images will serve as training data for the supervised learning model. Each image will be associated with a specific waste category, and this will provide the algorithm with examples that it will use to classify the images or the waste that will be provided to it in the future, or in when it's in operation. operation phase or the testing phases. If we are to continue, we shall talk of now unsupervised learning and in relation to our project of AI classification using waste sorting. Unsupervised learning approach is the one where the algorithm will use unlabeled data, and this one will be in a way that it will use raw data, and this will be images that could be images of any waste, and basically it will identify the patterns in these images and group them into certain categories. Basically, this one will be effective in situations where the data is dynamic and changes over time, and in this maybe you may not have classes or categories that you've already set aside for the algorithm to learn, but then it will have to observe this dynamic data and understand it and identify the patterns in it and classify that data. Yeah. So unlabeled data usage here will include using algorithms such as the clustering algorithms. The clustering algorithms, some of them will include the k-means. We shall use it, and this one will be employed basically, and this one will be used in a way that the data points are put in two clusters are known as the K clusters, and these ones are based on the similarity of the data. Yeah. If you have to move on, then we shall now let us look at the reinforcement learning method of machine learning. This one is where the agent learns to make decisions by interacting with the environment and receiving feedback in a form of rewards or penalties. This is whereby the agent's goal is to learn the strategy and the policy that maximizes the cumulative rewards over time. Yeah. So basically here, let us dive into what are the components of reinforcement learning. Yeah, but basically let us first illustrate what a reinforcement learning is. Basically here it's a simple example of a robot that maybe, let's say, it's given blue and red balls and it has to classify them. Here it will put them in a bucket, the red balls in one bucket and the blue balls in another bucket. By that, the reward will be its efficiency, how much it has been able to do it, and there will be a penalty if it has failed to do so. Maybe that's just a simple example of a robot of reinforcement learning type of machine learning. Basically here, the components I was talking of in reinforcement learning, we have the environment. Basically, this is the waste sorting system, and this could be a lump sum of waste, something. Then the agent, this is the decision-making algorithm that will serve as, this could be the neural network, all any algorithm or model that will be used to sort the data. Yeah, and the rewards here are the feedback that the agent receives from the environment in context, yeah, of whatever data you're dealing with. Yeah, so if I were to continue, we shall look at, sorry. It's, I think it's recovering. Yes, let's continue. Yeah, so if you have to compare these three classifications of machine learning, yeah, so supervised is highly effective in our case of AI powered waste sorting system, because here we need to categorize the waste into types and clusters. Basically, for easy management, if it's recyclable, then it can be taken back to the industries. If it's harmful, then it has to be disposed of in a very careful manner. Basically, here supervised learning will come in handy because the data will be categorized with labeled features and categories. Then unsupervised is very excellent in cases whereby the data is dynamic and we need to know the patterns of the data. Yeah, and reinforcement is also very useful in a way that it offers adaptability to the changing waste compositions. Yeah, there we can use reinforcement where data or where the waste can change over time and you don't know the composition of the waste. So which one is the best and why? I think if we had select, we shall go with supervised learning for our case. Then the challenges we faced with supervised learning is high dependency on labeled data. Then for unsupervised learning, it's subjective to interpretation. Basically, it will give you something that maybe you may not need for your case. Let's say for us, we need to categorize our waste into different categories, but then unsupervised learning will just give us the patterns of the data, which may not be the case that we need. We don't want to know the patterns of the waste, but we just want to classify the waste. So if you have to go with reinforcement learning, it's complex in terms of training the agent. Yeah. If in conclusion, basically this mode of ours is very efficient for developing cities because it will help to classify data and enable garbage collection to be easier, and disposal will be easier, and management of waste will be easier. Yeah. So these are the references to our these are the references to our work. You can check them out. Yeah. Thank you so much. I appreciate your